Hello, good morning. It's nearly the afternoon, but lovely to see you. Welcome to our third lesson of the morning. And I can see you've been waiting beautifully in the lobby. If it's your first time on the Click Meeting format, it does look a little bit different to when you've joined us before on the YouTube live stream. So, but it's going to be just as much fun, even more fun, in fact, because we've got more features to use. Yes, Miss is speaking. She is speaking now, so hopefully you can hear her. I have my video and my audio on. So please do share the links and let your classmates know that you are joining the lesson that you can actually interact with, not just watching a video or following links to websites and doing homework that's set. This actually is an interactive lesson where we can actually talk to each other through the chat and do some live quizzes. So we are going to do that today. We are going to have some live quizzes. No, you don't have a mic. We're going to talk through the live chat. So just to keep you safe, that's what we're going to do. So on the screen, we have got a brain teaser, a couple of brain teasers. So hopefully while you were waiting, you had a chance to start having a little look at those. So we did send these brain teasers to you via email, and they've been on our social media from hello, hi, from the last lesson. So it's nice. I recognize some names and some people are new. I don't know if you're new because you might have a different username on Click Meeting than you had on YouTube. So can you tell me, is this your first time at all? Or have you been doing these lessons before? Give me some idea. Who's here for the first time? I mean, at all. I know some people will be on Click Meeting for the first time. But first time, hello, welcome. Lovely to have you with us. Lovely to welcome new people and lovely as well to see some old classmates back as well. So hello, thank you very much. Great. So let's have a look at our brain teaser then. So the first one says Eva has a one-step function machine. Okay, so I'm sure you've all used function machines at school. You've all seen them. They're just a whole little sort of shape that says, okay, something happens to these numbers when they go in, the same thing happens, and then they come out having had those operations happened with them. So this function machine, we don't know what the operation is. We don't know what it does to numbers, but we can see when they go in and when they come out what happens. So number 6 goes in and it comes out as 18. What could the function be? What could the function be? Thank you. Oh, you've been with us since YouTube. An old classmate. Well done. And well done to people who hopped over. Well done to people who joined us. What could the function be? Okay. Yeah, it could be that 6 goes in and you multiply it by 3 and it comes out to 12. What else could it be? Doesn't have to be 3 times 6, does it? Could be something else. Hello, welcome, welcome. What else could it be? It could be 3 times 6. It could be something else. 12, what does that mean? The function can't be 12. It's got to be an operation. Multiplying, dividing, adding, taking away. It could be 6 times 3. It could be 6 plus 12. It could be add 12. Yeah. It could be, so it could be times 3. It could be add 12. Yeah. Because only given us one example. So it could be add, 6 add 12. Yeah, exactly. Could be 8 times 2. 2 8s are 16. 8 2s is 6. I'm not quite sure what that would how that would work. Exactly. It could be 6 times 2 plus 6. So it could be 2 lots of 6, add a 6. 6 plus 12. Yeah, so it could be a couple of things. Actually, it could go on even more. It could be 4 times 6 minus 6. It could be 5 times 6 minus 12. It could go on and on, couldn't it? So the idea is when you've got one example, you don't know what the function is. You need to have more examples. Okay, so on the next, well done for that. And now you really got the idea, well done. So on the next example, the function machine has given us 3 operations that have happened. 3 numbers have gone in and had an operation functioned. What was that operation? So what is the operation? What is the output from the function machine when 16 goes in? So first of all, Amir has put some numbers into a function machine. What is the output from the function when 16 is put in? First of all, you have to work out what that function machine is. Yep, good. You've used function machines at school. What is that function machine? When I first looked at this, I thought, oh, that's quite complicated. And I overcomplicated it. And then I thought, oh, actually, I can see it. It's quite simple. Who can see what it is? So 2 goes in. 8 comes out. 3 goes in, 7 comes out. 6 goes in, 4 comes out. What is happening? What is that function machine? What is the function of it? What is the function of it? What's happening to all of those numbers? To all of those numbers, what's happening? What happened to 2 to make it 8? What happened to 3 to make it 7? What happened to 6 to make it 4? I was confused when I first looked at it, and then when I worked it out, I thought, oh my goodness me, that is so obvious. Well done, bonds to 10. Well done, bonds to 10. Excellent. It is bonds to 10. So actually, you subtract them from 10. So 10 take away 2 is 8. 10 take away 3 is 7. 10 take away 6 is 4. They are bonds to 10. Oh, exactly. Oh, that's what I thought when I worked out. I thought, oh, come on, bonds to 10. So if 16 goes in, what comes out? If 16 goes in, what comes out? 10 take away 16. 10 take away 16. So let me just draw that function machine up so you can see it, because it's not as complicated as it seems. So 2 goes in, 8 comes out. What was the other one? 3 goes in, 7 comes out. 6 goes in, 4 comes out. Well, it is 10 take away the number. Okay, 10 take away the number. So 10 take away 2 is 8. 10 take away 3 is 7. 10 take away 6 is 4. So they're bonds to 10. So when you put 16 in, 10 take away 16, what comes out? Ooh, not 6. Somebody's got the idea. Oh, one right answer, I can see. It is a negative number. So if you've got 10 and you take away 16, well, you haven't got 16 to take away, have you? So you've got to go backwards. You take away the 10, so there's 10 on the number line. Oh, we can't see it. Let's go back up here to show you. So let's just do that. Let's just do that on the number line. Let's go big so we can see each other clearly. Let's just take that off from it. Okay, so here we are. Let's have 0 there. And there's 10 there. And we want to go back 16. We want to jump back 16. Now, we can't jump back 16 because we haven't got 16. We can jump back 10. So we can take away 10. But we've still got 6 to take away. So now we have to go -1, -2, -3, -4, -5, -6. So we have to go back all the way there. So 10 take away 16 equals -6. -6, okay? Not -4, because when you've jumped back 10, you've got 6 left. So you've got to do 6 more jumps. -4 would be if it was 14, wouldn't it? If it was 14. So -6. When you'd run out of positive numbers, you had to keep on going into the negative numbers. Woo! Negative numbers. Wow. Okay. So let's just have a little look. Did we do all of those? I think we had another little brain teaser to do. Yes, we did. So Dora has now put a number into the function machine. Okay, Dora has put a number into the function machine. Input goes in. It divides by 2. Output comes out. And we have got some clues for Dora's number. Can you use those clues and work out what Dora's number is? So the number is a factor of 32. It is a multiple of 8, and it is a square number. Can you work out what her number is? What number went in and what number came out? These are the clues. It's a factor of 32. It's a multiple of 8. It's a square number. Let's think about it. Yeah, I've seen. Well done. Somebody's got the answer. So it's come in, but let's have a look. Not enough people. Another person. So let's have a little look. 32. A factor of 32. It's a multiple of 8. Well, let's do our 8 times table. 8, 16, 24, 32. Okay. They're the multiples of 8. Half of 32 is 16. So the factor pairs are going to stop there. So it can't be those. And it's a square number. A square number, the same number multiplied by the same number. 4 times 4 is 16. So the number that went in is 16. The number that came out is 16 divided by 2. Very obvious. So 16 went in. Whoop. 8 came out. 16 went in. 8 came out. Now, sometimes when we look at those problems, our mind goes blank. Oh, I don't know it. Just take your time, make some notes. Okay. I thought, okay, 32. Let me go through multiples of 8. Let me see what cross over there. These are the numbers I've got to choose from. Which of those is a square number? Only 16. 4 times 4. Okay, just think about how to know a square number. 4 times 4. Square number is the same number multiplied by itself. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. They are all the square numbers. Okay, the same number multiplied by the same number. So it's called a square number because if you were doing the area of a square, the sides of a square are the same size, aren't they? So if that was a 5 centimeter square, every side would be 5 centimeters. So if we were going to find the area of that square, 5 times 5. Okay, a 5 square, a 5 square, a 4 square, a 3 square. Just think of it like that. The same number multiplied by the same number. Okay, so brain teasers just to get us started. Let me just close that brain teaser. Otherwise, when I go to open something else up, that will come back up as well. So let's just close that down. Okay, great. So we were looking at fractions and we still are. And today we're going to look at equivalence and we're going to take that a bit further as well. So we're going to do a little bit more detailed work on fractions. Now, fractions is often something, especially when we go into decimals and percentages, where people get a little bit wobbly. And in my lessons, what I want to make sure is that you are not learning tricks of maths, you are understanding it. Okay, so sometimes we do things and people say, oh, isn't it easy? But actually it just takes you back, consolidates that understanding, and then helps you to think about what's coming next. So I'm going to show you some fractions here. Okay, so I'm going to drop the screen down to look at these. Now, these fractions are not fractions of numbers. Okay, these fractions are fractions of shapes. We're going to do some work on fractions of numbers as well, because fractions, as we know, is splitting things into equal pieces, not splitting them into pieces, splitting them into equal pieces. Okay, right, so let's have a look at these shapes that we've got down here. Okay, I'm just going to drop you down to look at the shapes. I just want to look at one at a time. So when we split things into 2 equal pieces, we have halves, and each segment is a half, and we know that the numerator shows us how many we have and the bottom number says how many pieces, how many equal pieces something has been broken into, or numbers have been shared into, or quantities have been shared into. Okay, so this is a circle. It's been split into 2 equal pieces. Each piece is a half. This is a circle. It's been split into 5 equal pieces. Each segment is 1/5. So the total, how would we write the total number of fifths in that circle? If I said how many fifths are there all together to make the whole circle, how would we write that fraction? How would we write that fraction? If I said how many fifths do we have in total? How many fifths do we have in total that make up one whole? How would we write that? How would we write that? No, how many in total? Not how many are not shaded, how many in total? So to make a whole, there are 5 fifths. 5 fifths. And if you divide 5 by 5, if you make one group of 5 from 5, you end up with 1. And that's what that is. 5 divided by 5 is 1. It makes the whole. They all fit back in together to make the whole. If I had 20 pence and I divided it into 5 groups, I would have 4 groups, 5 groups of 4. If I put those all together, if I put all of the 5 groups together, I would have 20 pence again. I would make the whole, 5 fifths. So let's have a look at the next one. This circle has been divided into eighths. How would I write the whole? 1 whole equals how many eighths? 1 whole equals how many eighths? Okay, 1 whole equals how many eighths? How would I write that? Exactly. 1 whole equals 8 eighths. 1 whole equals 8 eighths. There we are. 1 whole equals 8 eighths. Let's just do another one. Ninths. 1 whole equals how many ninths? 1 whole equals how many ninths? How many ninths? 9 ninths. So when we've got them all, to make a whole, there is 9 of them, yeah? To make a whole, there are 9 of them. So let's ask a different question then. Let's ask a different question. What fraction of this shape, let me block out the other so you know exactly what I'm talking about. What fraction of this shape is not shaded? What fraction of that shape is not shaded? What fraction of that shape is not shaded? 5/5 is not shaded. 5/5 is not shaded. Okay, so let's just think about some other shapes and fractions. What fraction of this shape, circle I, is not shaded? Oops, get that paper over there. What fraction of this shape is not shaded? What fraction of this shape is not shaded? What fraction of that shape is not shaded? What fraction of that shape is not shaded? What fraction of that shape is not shaded? 7/10. Exactly, exactly. Now fractions, a lot of people, when I said, what do you think about fractions? They said, oh, shaded and not shaded. Well, that's because there are a lot of the examples that we use. So let's make sure that we're really clear that fractions is just splitting anything into equal parts. Okay, there's a Lego brick. What fraction of that brick is not covered by another brick? What fraction of that shape, that Lego brick, is not covered by another brick? What fraction of that shape is not covered by another brick? What fraction of that shape is not covered by another brick? What fraction of that shape is not covered by another brick? Okay, so the brick has 2, 4, 6, 8, 10, 12. Yeah, and 10/12 are not covered, or 5/6. It's the same thing. 10/12, 5/6. You can simplify 10/12, divide the top by 2, gives you 5, the bottom by 2 gives you 6. So not shaded, I said, remember, not shaded, not shaded, not shaded. Okay, so let's have a look at another one. Let's have a look at another one. Let me do this one then. Okay. What fraction of this Lego brick is not shaded? What fraction of this Lego brick is not shaded? And can you simplify the fraction for me, please? Okay, simplify the fraction into its simplest form. Into its simplest form. Can you simplify it, please? 34 over 36 can be simplified. 34 over 36 can be simplified. Okay, it can be simplified. Remember, simplified makes it down into its simplest form. What is not shaded? Okay, so not shaded. So not shaded, not shaded, not covered. So 2 are covered. How much is not covered? So we need to count, don't we? It's a 6 by 6 array. So there's 36 in total. So 34, 36 are not shaded. 34, 36 are not shaded. So we can divide by 2. The top gives you 17 and the bottom gives you 18. Now, I didn't think I could simplify that anymore. 34 and 36 do not have. Okay, I've divided with the top by 2, gave me 17 times 2 is 34, and 18 times 2 is 36. So simplified gave me that. Okay, simplified gave me that. Now, let's have a little look here. So here is 8 brick. If I cover 3/4 of that 8 brick, how many parts are covered? It's an 8 brick, and if I cover 3/4 of it, how many holes will be covered? It's an 8 brick, and if I cover 3/4 of it, how many holes will be covered? I have an 8 brick in my hand. I've covered 3/4 of it. How many holes will be covered? So 6 will be covered because 6 is 3/4 of 8. 6 is 3/4 of 8. So let's have a look at some other ways of thinking about fractions, because I don't want you to think about it's all about shaded parts. So if you joined my earlier lessons, you would see my infamous sheep. Let me make sure you can see all of them. 2, 4, 6, 8. There are 8 sheep there. Okay. That last one doesn't really want to join in. Come on, sheepy. Got a little wire over here stopping you being seen in all your glory. Okay, so I have 8 sheep there. First question about these sheep. These are the sheep left after 3/4 have escaped. How many sheep were there altogether? These are the sheep left after 3/4 of the sheep had escaped. How many sheep were there altogether? So 3/4 have gone. This is 1/4. So 1/4 is 8. What are 4/4? 4/8 are what? 4/8 are 32. Yet 24 left. You're quite right. 24 left. You're absolutely right. 24 is 3/4. These are the sheep left after 3/4 escaped. So you're absolutely right. 3/4 is 24. But the question was, how many sheep were there altogether? So in total, there were 32. Because this is 1/4. So we need to multiply this by 4 to find out what the whole was. 4/8 are 32. 4/8 are 32. Okay. 4/8 are 32. Yeah. So these are the sheep left after half of them escaped. How many were there in total? These are the sheep left after half of them escaped. How many were there in total? Still 8 sheep. These are the sheep left after half of the sheep escaped. How many were there in total? What was the total number? Not what was the other half. What was the total number of sheep when they were all there in the beginning? 16. 8 plus 8. 2 groups of 8. So let's have a little think about practicing our fractions. I'm going to do a little quiz now. So those of you who joined us for the first time wouldn't have done a quiz before. I'm just going to get the quiz up. Okay. So this quiz. If this is the fraction, what is the whole? Okay. So let's have a look through. You can scroll down by using the grey vertical line to the right of your screen. So I've spent 3/4 of my savings on a guitar that cost £150. How much had I saved up in the first place? If that was 3/4, how much was the whole? Two-fifths of our class are in the school basketball squad. These 14 children go out of class to train each Wednesday afternoon. Today, 2 non-basketball children are absent. So how many children are left in the class? Work it out systematically. Work it out systematically. Okay? Work it out systematically. Just think it through. Think it through. Fifths, and then you know the number. 2 of those children left in the class are away. Okay, 2 of those children are away. And then to the last question, just take your time, think about the maths. Okay, when you finish, just press submit. I'm just doing the survey as well to make sure that it all works properly. Okay. Nobody else can see your answer, so please do not worry about having a go and thinking that somebody's going to see. If you can't see the third one, on the right of your screen, there's a little grey button, a little grey line, a thin grey line. Use it to scroll down. It's a scroll line. I haven't given you your answers yet. I'll do the answers in a moment. Still got some people working their way through it. Only a quarter of the class have completed the task so far. So I can't see what you're putting individually, and nobody else can either. So please do not worry. Please do not worry about putting an answer up and thinking everybody else can see it. They cannot. Okay? Only you will find out what you individually scored. So just have a go. Just have a go. Just have a go. Okay? Just have a go. Yeah, nearly half of us are finished now. Just remember to think through logically. Okay? Think through logically. Think through logically. If that is 1/5, okay, then what is 2/5? If you know what 1/5 is, and you need to have 3 of them, multiply that by 3. Okay, just think about denominator and numerator. How many groups is it? How many of those groups do you have? If you have 1/5 and you know what it is, then you need to multiply by 5 to make it 5/5. Just think about what you need to do. Okay, so I'm going to give 10 seconds more. I'm going to give 10 seconds more, and then I'm going to close the quiz. Yeah? 10 seconds more, then I'm going to close the quiz. 5, 4, 3, 2, 1. Just going to end voting, and then I will share the results so that only you get to see what you've done. Now you see 2 circles coming up. One that says answers, and it will tell you how many of those answers you actually did. That tells you how many you completed. And the circle on the left tells you how many points you got. So each correct answer had 1 point. So if you got 3 out of 3 points, you got them all right. If you got 3 out of 3 answers, you got them all right. Okay, I just gave each question a point. Yeah. So if you got 100%, 100% is a whole. That means you got them all right. So that helps us with our percentages as well. Okay, so if you want to tell me how many you got right, if there was a question that you were a little bit struggling with, let me know as well. Okay, so they were just questions to help us apply our knowledge about fractions. The question about Granny, she was going to give some money, the same amount every day, and by day 3, they had £21. So you know, 3 days, £21. 3 watts are 21. 3 sevens are 21. So a week has 7 days, 7 sevens, 49. Okay. The basketball people, 2/5 of them went out, and that was 14. So 2/5 are 14. So 1/5 is 7. Yeah, so if 2/5 are 14, you know 1/5 is 7. because you split 2/5 in half. Half of 14 is 7. That's what you need to get down to. What is 1/5? Then you can multiply that up. Okay, I know what 1/5 is. So 5/5 are 5 sevens, 35. Yeah, 35 children in the whole class. So 2/5 of them go out, 14 go out, 35, take away 14, leaves you with 21. But 2 of those children were away. 21 take away 2 is 19. Just take your time and work your way through, okay? Take your time and work your way through. Right, okay, so the other thing I want us to look at is equivalence. Well done for that. I'm going to close that up and we're going to do a little bit of work on equivalence today. We've started doing some already. We've started doing some equivalence work already. Some of it's come up in our conversations already. But tell me something about equivalence. I'll put an equivalence board up there for you so you can see it. Tell me something about equivalence. I am going to write 3 fractions up here. I have 3 different color pens. I am going to write 1/2. I am going to write in a different color 1/3. And I am going to write in a different color 1/4. So using what you know about equivalent fractions, and equivalent fractions are, you know, would you rather have this or this? I don't care, quite frankly, because it's exactly the same. Would you rather have half the cake or 2/4? Do you know what? It doesn't matter. It's the same quantity. Would you like to have half the money or 2/4? It doesn't matter. It's exactly the same. The cake might have 2/4 pieces, but when I put them together, it's still just half the cake. Okay, so let's think about equivalent fractions. What fractions are the same? What is the same as a half? What is the same as a third? What is the same as a quarter? What, if you put all those pieces together, would come to the same as a quarter? Okay, what would it be? So can I have some ideas? You can say a half equals this, this, this. A third equals this. A quarter also equals this. And I'll write them on the board. Let's see how many we can get coming in. Let's have a look. I've got the fraction board up there to help you. Can you think of any other fractions that are the same as 1/2? Any other fractions that are the same as 1/2? 2/4. We've got an idea. What color pen is that? Thank you very much. 2/4 has come in. 2/4 is the same as a half. Any others the same as a half? Hello, hello, hello. 2/6. Tell me what you're saying that they're equivalent to. Right, half is 1632. Well done. Very clear answers there. Thank you. A half is the same as 1632s. Yeah, so you're saying 3/6, that is a half. Yeah, can you put equals a half? Because some people might have gone on to the other one. So 3/6 is a half and 4/8 is the same as a half. So let's stay on a half for a while. Okay, we've got half, 3/6, 4/8, 5/8 is not a half. 6/12 is a half. 6/12 is a half. 7/14 is a half. Anything else? Okay, thank you very much. That was clear. 2/6 is equal to 1/3. Okay, let's go on to my different color pen. A third is also 2/6. I can multitask. 5/10. Okay, meant 5/10. Well done. Oh, which color pen am I using? Quick, 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 quick. Oh, you're so quick. 5/10 is also equal to a half. What else about 12/24? Thank you very much. 12/24 also equal to a half. What else have I got coming in? Ooh, 30/90 to a third. Thank you for that clarification. Very helpful. 30/90 is the same as a third. 10/20. Oh, well done. 10/20. Oh, red pen. 10/20. 10/20. Let's move on to a third, or 50/100. I'll add that on. Let's move on to a third. Come and give me some other equivalent fractions to a third. I've got 2/6. Oh, 2/8. What are you saying that's equivalent to, please? 2/8 is the same as what? I need to know where you want me to put that. 2/8 is the same as what? As 1/4. I will accept that because it absolutely is. 2/8. Right, so I'm putting my red pen down now and I'm looking for third and a quarter. Okay, third and a quarter I'm looking for. 3/6. We got that's a half. 4/16 or a quarter. Thank you very much. 4/16 or a quarter. Yep. Yep. Any more? Any more for a third or a quarter? Any more for a third or a quarter? Any more for a third or a quarter? Any more? Think about what you were doing for halves here. You were using some sort of pattern. Using some sort of, oh, we go, 60 90ths. What we saying that is? What we saying that is? 60 90ths. What we saying that is? What we saying that is 60 90ths. Yeah, it's 2/3. I'm asking for a third. So if 60 90ths is 2/3, what would 1/3 be? That's 2/3. If 60 90ths is 2/3, what would 1/3 be? What would 1/3 be? Oh, we've gone even bigger now. 300 900ths. Okay, why not? Let's go up there. 300 900ths. Still got that ratio there. That's fine. And 30 90ths. Thank you. 30 90ths. Brilliant. Okay. Okay. 2/6, a third. Have we got that one on there? Yep, we have. A quarter equals 20. Oh, no. A quarter equals 28 over 32. Then we'd have to have 4 lots of 28 would be equal to 22. So no, that's not quite right. You can split 32 into a quarter, but I think you might have made a mistake on the top number. Have another look at that, please. 28 over 32 is through. No, it's not even that. 3,000. Oh, my goodness, we're going mad now. 3,000 over 9,000. You are getting that ratio really nice, really nicely. Okay, 20 60ths. Yep. Okay. Oh, are we going to a half now? Yeah, we're going to go decimals on the half. Okay, lovely, thank you. 0.9 over 0.8 is the same as a half. 2/6 is 1/3. 2/6, we got that. Let's have some more quarter ones. Down here. Check your zeros on that 200,000 over 60,000. Check your zeros, please. Let's have a look at some quarter ones. Let's have a look at some quarters. We've got 30,000 over 90,000. Yeah. Well, we would need some real simplification going on here, wouldn't we? Because we wouldn't really want to deal with fractions with those huge numbers. A quarter equals, can I ask you to look at that one again? A quarter equals 24 32s, because you have to multiply the top by 4 to make it the same, and 4 24s is not 32. 4 watts are 32. 4 watts are 32. And that's what's going to go on the top. Break 32 into 4 equal groups. If you shed 32 by 4, what would you get on the top? If you shed 32 by 4, you would get 8 exactly. So 8, oops, wrong color pen. 8 32s. What else is snuck in there? 2,000 over 8,000. These are very big numbers. Okay, 8 over 30. Thank you very much. Good girl. 6 over 24. Excellent. Well done. Really good reflection. Oh, we got a decimal coming in there. Decimal 0.25 over 1. Exactly. That is the same as a quarter, isn't it? Okay. Brilliant. Show me some brilliant thinking there. Okay, 16. Yeah, 16 over 64. 4 16s are 64. Okay. So we are getting the idea. And I'm going to drop you down onto the table, because I want you to really explain to me how you were able to do these numbers and why I was able to say to you, oh, that's not quite. Okay, great big number at the bottom. Remember, we would always simplify fractions down to their simplest form. So we wouldn't be going around having big numbers like that. We'd either make it a decimal or we would simplify the fraction. Let's drop down. Okay. Oh, sorry. I still got the fraction board up there. So let's close that down. Otherwise, you're not going to be able to see a very big screen. Okay, let's drop down again. Let's try that again. Drop down, take 2. Okay, so let's have a look at halves. Okay. Tell me something about all of these numbers that is the same. It's to do with the ratio, why you could scale up and say halves was 32 16ths, 14 7ths, 20 tenths, 10 fifths, 8 fourths, 3 sixths, 4 eighths, 3 sixths, 5 tenths, 10 20ths. Why could you say all of those were a half? Tell me something. Yes, there are 2 quizzes. I'm going to do another quiz in a little bit. Tell me something about the ratio. Tell me something about these numbers. What is it that you are doing? Why are all of those equivalent to a half? Why are all of those equivalent to a half? Let me see your thinking. Tell me. Let's look at what happens to all of those numbers. Yeah, the numerator is half of the denominator. So the relationship always stays the same. Any fraction that is equivalent to a half, the numerator will always be half of the denominator. So I've got 4 equal pieces. Well, if you have 2 of those, that's the same as a half. There are 6 equal pieces. Well, if you have 3 of those, that's the same as a half, because 3 is half of 6. Well, there are 8 equal pieces. Well, if you want to share those in 2 groups, there's 4 each, because 4 is half of 8. What 10 equal pieces, if you want to share those into 2, 5 each. Okay, so the ratio, the numerator is always half of the denominator. And then that is the same for thirds. Third, the numerator is always a third of the denominator. 6 divided by 3 is 2. 9 divided by 3 is 3. 12 divided by 3 is 4. 15 divided by 3 is 5. 18 divided by 3 is 6. So they will always be in that same ratio, 1 to 3. 3 times bigger, 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 or you can say 3 times smaller, 3 times smaller, 3 times smaller. The same is the same for quarters. 4 times smaller. 2 is 4 times smaller than 8. 3 is 4 times smaller than 12. 4 is 4 times smaller than 16. 5 is 4 times smaller than 20. So it's always in that same ratio. Okay, the same for fifths. Any fraction that is equivalent to a fifth will always have the top 5 times smaller than the bottom. 5 times smaller, 5 times smaller. Okay, so we can use that equivalence. So we're going to do a little quiz on equivalence now. Okay. Yeah, Lego's coming. Don't worry, Lego's going to come. Let's have a little look at another quiz. So this time we are going to find fractions where we have more than 1 on the numerator. Okay, so we know our fractions. We're going to divide by the denominator, multiply by the numerator. Divide by the denominator, multiply by the numerator. Okay, so I'm going to do mine here so I can just check it's all working properly. So 5/8. I'm going to divide by 8, multiply by 5. What's 1/8? And then what's 5 of them? Okay, let's be really clear what we're doing. 3/4 of 200. Well, what's 1/4? And then what's 3 of them? Okay. Yep, I'm just getting some money and some Lego sorted out while you are busy doing that. Yep. I can see the answers are coming in. The answers are coming in. The answers are coming in. Now the Lego police are still here. If you didn't meet the Lego police last week, they are still here. Yeah, I'm going to give 10 more seconds. 10 more seconds. Okay. Nearly done. Over half of you are nearly finished. So remember, you're dividing by the denominator to find out what one group would be. And then how many groups do you have on the numerator? Then you multiply by that. Okay. Okay. Did it. Finished. Okay. 5, 4, 3, 2, 1. Okay. I'm going to share your results. So remember, you're looking at your results. Yeah. 100% of questions answered. How many got right? 3 out of 3, 2 out of 3, 1 out of 3, and then the points that you got. Okay? Yeah? Right, a few more little corrections before we finish. And then next week, we're going to start looking at adding fractions, adding and taking away, and use that. Okay, so don't worry if you got 2 out of 3, as long as you can think about where you went wrong. Remember, when you're doing fractions, if you're trying to think of 3/5, you first of all got to think, what's 1/5? And then find out what 3 of them are. Find out what 1 is, and then you can work. Yeah. So 2/3 is the same as, well, actually, in terms of percentages, it's 66.6 recurring. When you do a third, it's a bit of a tricky percentage, but 67% is rounded up. So that's brilliant. Yeah. So, okay, let's just have a little look at a few more sharing things. We're going to close that down and come back together. There we are. And let's come back together so we can see, you can see me. So here's a little Lego figure here. Here's a little Lego figure. That little Lego figure has a quarter of the money. That little Lego figure has a quarter of the money. In case you can't see, that's a £1 coin and a 10p coin. So how much money did I need for all my friends to have the same amount? If that's a quarter, how much was the whole pot? Yep, clone troopers are coming in. If that's a quarter, how much was the whole pot? I thought I should use some Star Wars people because it was Star Wars Day yesterday, wasn't it? May the 4th. May the 4th be with you. So it was Star Wars Day yesterday. So how much was the whole amount? There we are. Let's put him in and then you can come out. How much was the whole amount? If £1.10 was a quarter, how much was the whole amount? Okay. And the fraction police are here to make sure that fractions are done fairly. They are here on the job, parking up here, check in. Yep, could you move down there, please, sir? Thank you very much. Just check in that everything's happening as it should. So how much is the whole amount? I'm not seeing any answers coming through yet. Thank you very much. Just saw our answer. So if that is 1/4, remember that is one group of 4. And the 4, how much would it be for all of it? So if that is one group, if you had 4 of those groups exactly the same, how many would it be? If you had 4 of those groups exactly the same. Well, there's another one exactly the same. There's another one exactly the same. There's another one exactly the same. Okay, so that was 1/4, 2 quarters, 3 quarters, 4 quarters. Okay, so quarters equal £4.40. £4.40. Okay, so let's have a look what else we can do. Will I get some money sorted out? Yeah, the fraction police are quite happy with that. Nothing to see here. Okay, be careful. Right, so those stormtroopers are going to go over here. Lego brick. Now, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 whole Lego brick. A bit difficult to tell because it's black. I just hold it up there so you can see. How many holes will I have to cover a quarter? How many holes will I have to cover a quarter? How many holes will I have to cover 1/4? It's 20. There are 20 holes on there. How many holes will I have to cover a quarter? How many holes? A quarter of 20. So you're splitting 20 into 4 equal groups. 20 into 4 equal groups. Think about your times tables. Think about your times tables. Exactly. I will need to cover 5 holes. Here we are. There's a 4 one and there's a 5 one. Now, that's a quarter covered. I could do that another 4 times. What would I have to add to cover half of it? What would I have to add to cover half of it now? What would I have to add to cover half of it? I have to add 10. I have to add another 10. Be clear. Say to me, another 5. Okay, so there's another 1, 3, 5. Now I have half of the brick covered. 10 and 10 equals 20. Okay. I have a brick here, and I have covered a third of it. I have covered a third of this brick, and I have covered 8 holes. So how many holes does this brick that I am looking at have in total? I have a Lego piece here, and I have covered a third of it, and that means I have covered 8. So how long was the piece in total? How long was the piece in total? If I have covered 8, how long was the piece in total? I have covered a third of it, and that is 8. So you're thinking, okay, if 1/3 is 8, 3/3 must be 3 times 8. And what is 3 times 8? I have not seen a correct answer coming up yet. I have covered 1/3. So there's the brick, and I have covered 1/3. 1/3 is 8. So I must be able to get another 8 and another 8. And 3 8s are, thank you. Oh, a little bit of a typo there. 232. 3 8s, thank you, are 24. Times tables, 3 8s are 24. So I had covered 8, and that was 1/3. Okay, that was 1/3. 8 was 1/3. So I must be able to do another 8 and another 8. 3/3 make 1 whole. 3 8s are 24. Okay, so here is a fifth of my money. Here is a fifth of my money. How much would 2/5 be? If that's a fifth of my money, how much would 2/5 be? How much would 2/5 be? If that's 1/5 of my money, what would 2/5 be? If that's a fifth of my money, what would 2/5 be? Ooh, what's your maths? What's your maths? If you're doubling that, what's your maths? So if that is 1/5 of my money, oh, you can't see, a 20p and a 2p. A 20p and a 2p. Okay, so if that's 1/5, what would 2/5 be? Thank you. What would 4/5 be? What would 4/5 be? What would 4/5 be? Okay, so knowing what 2/5 are, knowing that 2/5 is 44, what would 4/5 be? Now remember what I say, you would first of all have to work out what 1/5 was. So 1/5 is this, multiply it by 4. Knowing what 2/5 is, you can just double it. 88 pence. 88 pence. 4/5, 88 pence. What's the total? What's 5/5? What does 5/5 come to? What does 5/5 come to? What's the total? What does 5/5 come to? What's the total? What's 5/5? If they're all there, what's 5/5? Ooh, no question marks. Work it out. Work it out. Haven't seen the answer yet. Have not seen the answer yet. Still haven't seen the answer. Still have not seen the answer. 4/5, 4/5. Okay, 5/5. 5 20s are £1. 5 2s are 10. £1 and 10 pence, or 110 pennies. 5 20s are £1. 5 2s are 10. Okay. £1 and 10 pence, or 110 pence. Yes. Okay. Well done. Good work today. Hard work today. hard fraction work. Now, if you did not get all the answers, or if at any point you thought, not feeling confident about that, please join the earlier lesson as well next week. Please join me at 10 or 11 as well as this lesson. Still come to this lesson, because you just get more of a chance to have those explanations. You just get more of a chance to see what comes before in terms of thinking. So well done today. Little well done, well done, well done. Well done from Rexy as well. Been lovely to see you. Okay, so come and join us next week. Please make sure that you subscribe. Okay, we're going to put the quiz up for you. Please make sure you subscribe. Come and join us. Get the emails next week.